Hello everyone, I'm Jacob Kaufman, I'm the nerd on the street, and today we are talking about how to compile software from source. Alright everyone, so here on this channel, most of what I talk about involves free and open source software. And of course, the entire point of open source software is that the source code is available for you or me or anyone else to go and download and view. Now, of course, just because the source code is out there doesn't mean we use it all the time. Most of the programs that I use on a daily basis I've installed from binary packages on my computer. The source code is out there, but I don't need to download the source code to run the program. I need to download the binary. However, every now and then you might find yourself wanting to compile a program from source code. That's taking the source code that you can read and modify and translating it into a binary that your computer can actually run. You might want to do that if you're installing a program that is not available in your distributions repositories, or if you want to try making a tweak to a program. I've done videos before about hacking on some programs that either didn't work on my computer before I hacked on them or they didn't meet my needs. I downloaded the source code for GNOME Music to try and add some extra functionality. A couple years before that, I updated the source code of Untrunk to make it run with 64-bit variable types. So I've got a little bit of experience compiling programs, but really it depends on the program that you're wanting to compile. I had a viewer ask me this question in a comment. They asked me basically to make a video about compiling programs from source. And really it's going to be different depending on what program it is, what language it's written in, what compiler you're using, that sort of thing. So today I'm going to be showing you how to compile 3 programs. These are just samples. I've picked one program from the KDE project, one program from the GNOME project, and then one third-party program just for good measure. Now in a moment here I'm going to cut to the desktop and we're going to walk through compiling all 3 of these programs from source. Before I do that, I do want to let you guys know this video is not going to be one of my super smooth videos where I've done this in advance and planned everything out perfectly. I actually started doing that. I was going through the first one of these programs and I was trying to compile it and I was running into some problems and researching how to fix them. And then I stopped and I realized, I could have kept going and figured out how to compile these 3 specific programs, and I could have made a really good video on how to compile these 3 specific programs, but that would not have really shown viewers how to compile software in general. As with anything in technology, compiling does take some troubleshooting. It takes research skills, and it's reading documentation and figuring things out based on error messages. And really, if you're new to compiling software and you want to learn how to do this so that you're not just compiling these 3 programs I'm about to show you, but you're able to compile any software that you find online, it's going to be more beneficial if you see the entire process start to finish. So that's what I'm going to be showing here. We're going to cut to the desktop and I'm going to try compiling some programs. As always, if you guys have questions about specific programs, feel free to leave those either in the comments section below or even better at the forums at nerdonthestreet.com. I'd be happy to go back and forth with people on my forums if you're trying to build a program from source for Linux and you're having trouble. I'll take a look at the error messages you're getting and try and point you in the right direction. But for now, that's basically what we're doing, so I'm going to go ahead and cut to the desktop. Alright guys, and here we are on the desktop. I do have my 3 programs pulled up here that we're going to be compiling today. The first one is Krita, which is from the KDE project. It is an art program, vector-based. So I've got the source code for that pulled up here on the KDE Invent GitLab instance. After that, we are going to be compiling GNOME Nibbles. That is a worm game for GNOME. It's one of my favorite games on the Linux desktop. It was one of the first programs I ever ran on Linux, and it's still being maintained. So I've got that pulled up here on the GNOME GitLab instance, and we will compile that in a little bit. And then to end off the day, we will be compiling Super Tux Kart. This is a program that is hosting its source code on GitHub here. It's a racing game. It's sort of like Mario Kart, but it's got Linux-themed characters in it. So that will be our finale to the video. But to start off, we will go back to Krita here. I don't actually use Krita myself, but it is a very popular program in the KDE and Linux community. And we're going to clone this repository in a moment to get a copy of this source code. However, first, I do want to mention that technically I'm not actually starting from a clean slate. If I open up a terminal here, and this is going to be a terminal-heavy video, I can cat out my etc/os release, and you can see that I am running Arch Linux. Now, Arch Linux has something called the Arch User Repository, which actually requires you to install a lot of developer packages in order to use. If I go to the Arch Wiki here and I search for AUR, we'll go to the prerequisites section here, and there is this base devel group This is a package group that I installed on Arch Linux basically when I set the system up, and it includes a few tools here. Some of them like grep or sudo you're likely to have installed already, but some of these like autoconf or GCC is a very important one. This is the actual GNU compiler collection for compiling C and C++ executables. Tools like those or like make, these are things that might not be installed on, say, an Ubuntu installation by default. So if we just search start page for Ubuntu compiling prerequisites, if I can spell prerequisites right, you can see there's an Ubuntu wiki page here on how to compile. So it looks like Ubuntu also has a package group called Build Essential that you'll want to install. And if you're using Ubuntu, you should definitely read through this documentation here. If you're using Fedora, I'm sure we can search the same thing for Fedora. And once again, I know I'm not showing you this stuff in its entirety. I'm just trying to give you an idea of what you should be looking for if you're attempting to do this and you're having problems. You should start by looking for just the general stuff that you need to have installed on your distribution in order to successfully compile any program. But now we're going to look at Krita in particular, and one thing that you'll always want to do if you're trying to compile the program, the first thing you should really do is look for compiling instructions in the program's documentation. We're here on Krita's GitLab page on the KDE infrastructure, like I said, and we've got our user manual here, and here we have development notes and build instructions. So this is instructions for building, compiling this program. Now I did take a look at this before, and these instructions aren't entirely clear. You can see they link to this guide on a third-party website here, which is actually a little bit outdated because the third-party website then links back to updated instructions on krita.org. And we're going to basically try and use these instructions on krita.org. So I've got my file manager here, I've got Dolphin. You can see I'm just in a regular old directory on my system. I am not going to be installing any of these programs into system locations. I'm going to try to compile all of them so that I can run them out of just a regular folder and then delete them when I'm done. I don't like to put self-compiled packages in my system directories. I only like to place files into system directories using a package manager so that I can go and clean up later if I need to. So here in this folder, I'm going to create a new folder called Krita. And inside of there, I guess we can start by going ahead and cloning the source code here. So we are going to go back to GitLab and we are going to get our HTTPS link. I've just copied it to my clipboard with Control-C. Now Dolphin File Manager has a really cool feature here where I can basically split the window into two panels here, and one of them is going to be a terminal. So I'm going to be using that for this video just so that we can see in real time both the file system and the commands that I'm using to make it a little bit easier for you to follow along visually. So if you don't have Git installed, the program Git, you should be able to run this and get some output. If you don't have that installed, get it from your distribution's package manager, that's Git. And so the first thing we'll do is run Git Clone on our project link here. It should end in .git. So we will clone that. It's going to put it into a subfolder called Krita. So right now we are downloading the source code for this program. All right, so now we have this folder called Krita. We can go into that folder, if I spell it right, there we go. And we can scroll through here and you can see all of these files in the Krita folder. And these are the exact files that we were looking at over here in our web browser. You can see third-party benchmarks, build tools, CMake. These are the same directories, third-party benchmarks, build tools, CMake, that we now have on our local system. We have just cloned that remote repository. All right, I'm going to zoom back out here so that we can see a few more of these files at the same time. We're going to go back up one directory. And like I said, I already sort of started doing this Krita compilation, and I did find out we're going to need 3 folders for this in total. So we are going to make dir for a directory called compile, and we are also going to make another directory called install. I didn't make it all the way through this process yet, but basically we are going to have our source code in here in the Krita folder. However, we can't actually compile in the same directory, at least in Krita's case. We can't compile in the same directory that our source code is stored. We want to leave this source code alone, and we're going to compile inside of this compilation directory, and then we are going to place our finished runnable executable inside of this install folder. It's a little bit convoluted, but that is what our instructions over here are basically telling us. As you can see, the most convenient layout is as follows. We've got one folder for the source code, one folder for compiling Krita, and one folder for installing and running Krita. All right, so we've already gotten the source code. We don't have to worry about that. Now you can see here there's a CMake command that we are going to run. and we're going to run this from within our compile folder in our case. So the instructions are telling us to use a program called CMake, and this just happens to be a program that a lot of the KDE programs use to compile themselves. So here's the command we're going to use first. It is CMake, and we are going to run CMake on the Krita folder. This is the lowercase Krita folder. This is where the source code is stored. And we're going to pass some options in. One of them is dcmake_install_prefix. This is the location where we're going to install the built binary to. We're going to use that folder that we just made, but we can't just use /install. For this option that we're passing in, we actually need this to be the complete path of the folder. So for that, we are going to use my home variable, that's $home, should be your home folder or directory. And in this case, we are in home/videos/compiling. And I'm going to use a / here to escape my spaces in the folder names. Compiling software from source/install. So that's the folder that we created a moment ago that we're going to install to. We are going to pass another option called dcmake_build_type equals debug. And this is one I have experience with from Kdenlive. Kdenlive is another KDE program, and when I install Kdenlive from the Arch Linux package repositories, or most distributions package repositories, Kdenlive was not built with debug symbols, which makes it very difficult to report bugs. If you ever find yourself needing to report a bug and you find that there are no debug symbols in your crash report, you can fix that by compiling the program with the build type set to debug. This will compile the program with the debug symbols included. It does not slow down execution in any way. All that it does is take up a little bit more disk space. And finally, we can pass our last option, dckrita_devs equals on. And to be honest, I'm not entirely sure what this means off the top of my head, but it is in our instructions here. So we are going to run this, and we're running some things. And we are going to get an error message here. All right. So you can see here we got an error message, and we're getting a lot of text here, so I am going to zoom out just a little bit. But this says, configuring incomplete, errors occurred. Now this might look like we've got a big problem that we don't know how to fix, but if we go back to our documentation here, they actually tell you, unless you've installed all the dependencies Krita needs on first running CMake, CMake will complain about missing dependencies. And actually, I'm not sure if we got this particular message anywhere, but this error was caused by us not having a dependency that is needed to make this program. So we're going to scroll up here a little bit, and let's actually run through all of our CMake output here. So when we're running CMake, it's going to tell you some information about your compiler. We're using the GNU compiler collection, GCC. We've got some deprecation warnings, which we can generally ignore. That's more for the developers to worry about and not us. You can see we are compiling Krita version 4.3.0-pre-alpha, so maybe not the most stable version of this program. And we're going to run through a bunch of tests here. Now you can see here that we're getting a message about unable to find the boost header files. We'll come back to that later. For now, though, we're going to keep going, and we've got a traceback here, no module named sipconfig. Tracebacks are generally where we find problems. We'll keep scrolling. All right, and here we've actually got a really helpful section of output from CMake. It says, it's listing the packages that we've found first. So the following recommended packages have been found, GSL. So this means that Krita is going to compile the transform tool here. If we didn't have GSL, we might still be able to build Krita, but we wouldn't have the transform tool. Required packages, on the other hand, we need those to build this program at all. You know, the KDE frameworks, for instance. So it's found all of those recommended packages. That's good. Now here it's saying the following optional packages have not been found. And let's actually open up a text document here. And you'll want to do this too if you're compiling a program and seeing these types of messages. So this is a list of packages we need to install. All right, so we're going to start a list. Sip, we need VC. Those are both optional, so we don't need them, but these next couple we do absolutely need because they are required and they've not been found. So boost is one, and quasip. And you can see what actually killed our compiling here was boost. CMake was trying to use the boost include dir variable, but this variable was set to not found because we don't have boost installed. So it was trying to use that variable in all these different locations, and of course that failed miserably because the variable was not set because we don't have that library installed. So let's clear our output here, and we are going to install these packages. Now, I need to find out what these are called in my particular distribution, because the package in Arch Linux or Ubuntu or Fedora might not match the name of the actual program. The capitalization might be different, there might be extra words or version numbers or things after. So we're going to go to archlinux.org. Now, if you're on Ubuntu, you should be doing this on Ubuntu's website. Let me Google Ubuntu packages. I know that there's a, here we go, packages.ubuntu.com is where you would go for this if you're using Ubuntu. If you're using OpenSUSE, you would go to software.opensuse.org, which is a great web interface for searching through OpenSUSE's packages. There are websites for Debian packages and all the other distros, but I'm on Arch, so we're going to be searching. Let's locate the SIP package first. So I'm just going to search SIP. And look at that. We've got a package just called SIP, a tool that makes it easy to create Python bindings for C and C++ libraries. That sounds like what we want. So it's just called SIP in all lowercase. So we'll note that down. The next one that we're going to want is VC. Once again, these two are optional, but looks like this one is here as well. Also has to do with C++ code, so it sounds like this is the package we want here. Next up, this one is required. We need Boost. And if I search for Boost, oh, looks like it is out of date, but we do have it in our repository. And oh, it's been out of date for a little while actually, but it is in the official repo. This is not an AUR package. So we will go ahead and throw that on our list to install, and then Quazip. Quazip, C++ wrapper for zip and unzip C package. All right, and we will jot that package name down. So we'll minimize Firefox, and let's install all 4 of these packages here. So we will sudo pacman-s zip vc boost and quazip. You should be doing this with apt if you're on Ubuntu, dnf if you're on Fedora, zypper if you're on OpenSUSE, etc. And we have installed those 4 packages. All right, now I want to just make sure we're starting from a clean slate, so I'm going to go ahead and just remove everything in this directory. I don't know if that's actually required or not. It just seems like a good idea. Now I am going to copy and paste my cmake statement back in here, and we will try running that again. All right, configuring is done. Looks like it still didn't find SIP, even though we do have it installed, but that's okay. All right, and you can see configuring done, generating done. So even though we had some warnings here, build files have been written to this directory that we're in right here, /compile. So what we just did was actually just configuring. It was our system going out, figuring out which features we're going to enable and which features we can't enable based on the packages that are and are not detected. I am curious why SIP was not picked up. It says required version is 4.19.13. If we go back to our packages here, what version did I just install? 4.19.18, yeah, so we should have had that. Maybe it was Python 2-SIP, or I guess Python 3-SIP. I kind of want all the functionality here. I'm not actually going to be using this program a ton, but let's just try installing sudo pacman-s python-sip. Let's try installing that. Let's clear our screen, and I am going to just delete everything in this directory again, and I want to run that cmake one more time. I want to get a full-fledged, full-featured application if I can here. All right, it looks like we did detect SIP this time. Once again, we got a warning, but the build files were written here. And if we scroll up a little bit, I saw where it was talking about detecting SIP. The version of SIP found is 4.19.18. So that's a perfect example. It was telling us we needed SIP, so I installed a package called SIP. But in this case, we didn't actually need the package called SIP. We needed the package called python-sip. So it's a little confusing. The package names in your distro don't always match what the source code refers to it as. So you just have to kind of play around, search through your distro, be resourceful. As long as you're only installing things from your distribution's official repositories and not anywhere third party, you should be generally safe if you accidentally install something like I accidentally installed SIP that I didn't really need. I'm not too concerned about that. It's in the official repo. I can uninstall it later so it's not just hanging around on my system, but really there was no harm done there. So that's great. We've got our build files now, and we will go back to our instructions here. And now that we've got our build files, we can go ahead and actually build Krita. We do that by using make. Now by default, make is only going to use one CPU thread. And I've got experience with this from using the AUR here on Arch Linux. Only having one CPU thread available does make compiling things quite slow sometimes, depending on the size of the program. As you can see here, I am on an AMD Threadripper processor, so I have 16 threads to work with. I don't want to be limited to only using one thread for compiling here. That is going to be very slow. So we could just run make right now and it would build the program. But first, we're going to do what they're telling us to do here. We're going to cat out our proc CPU info file, and we're going to grep for the word processor, and we're going to list out the number of lines that there are. And that's actually a clever way of doing it. Basically what that was just doing was counting the number of times that the word processor appeared here. As you can see, we have processor number 15 here, processor number 14, going all the way back to processor number 0 at the top right there. And I already knew that I had 16 threads because I just showed you the graph there. But that's how you can do it on the command line. And so now we know we have 16 threads to play with. I'm going to use all 16. Actually, I'll go ahead and I'll only use 8 threads to compile because I am screen recording and recording my audio and everything. I don't want other things to get hung up while I'm compiling. So we are going to run make-j8, which is just going to make our binary. This is the number of jobs running, so number of threads, and we're using 8 threads. I'll hit enter, and we are going to compile. If I open up my system monitor, you can see the CPU usage is starting to go up there. If I go into my process table, you can actually see, if I sort by CPU, you can see all of the CC1+, this is the GNU compiler collection, starting up threads, and the threads are ending, and it's starting more. But there's 8 going at any given time that are compiling this program. And this is just going to take a while. It's going to depend heavily on the speed of your processor. It is going to depend on the speed of your I/O a little bit as well, maybe how much RAM you have, but really it's largely about your processor. And basically 8 of these lines are running at any given time, is my understanding, because we're using 8 threads. This is taking a few minutes even on my system here. All right, and this has actually taken a good 20 minutes or so, maybe 25 minutes on my system here using 8 threads. That's a little longer than I expected, but like I said before, I do know that Krita is a very complex program. Lots of code, lots of things going on here. But we are finally nearing completion, 98%, 99%, and 100%. All right, and we built Target. Oh, the last thing that it built was the Krita sketch plugin, but we are done building Krita. So let's just take a look at our instructions to verify what's going on. Next up, we will need to run make install, yep. So make basically took the source code and it compiled it into binary files that our computer can run. Next up, we are going to run make install, and this is going to install those binary packages that we just built with make. It's going to install them into the location that we specified earlier as our install directory. This one's going much quicker, as you can see, because these targets are already built. It's just installing them into the proper directory structure so we can actually run the program. All right, and there we have it. So now we can cd out into our containing directory and cd into our install folder. And there's nothing in here. Interesting. All right, well, let's go back one and go back into our compile directory. Home Jacob videos, compiling software from source. I'm gonna cd into this directory. Did I make a typo somewhere? cd. All right, I made a typo somewhere. Where was the typo at? Ah, I see. So we made our install folder inside the Krita folder. So that was my mistake. I meant to install into this install folder here, but we actually created another install folder up one level. But now we can come into here, and you can see these are the files that would make up this program on our system. Now, we absolutely could have installed this onto our system by running sudo make install, and it would have placed it into our actual lib64, bin, etc, and share directories on our computer. Like I said before, I don't like to do that with self-compiled programs. I like to leave the actual system directories for my package manager to manage for me. That's not to say I don't install custom packages sometimes, but when I do, I like to make a package. You know, it's fairly easy to do that with the AUR here in Arch. But we have installed into this auxiliary folder here, so now we can cd into our bin directory, and we can launch Krita here. Now I just want to show you, I do not currently have Krita installed. If I run, let me just go back up one directory. If I run Krita command not found, you can see it's not on my system. I can do pacman-qi Krita, and you can see I don't have Krita installed. I don't use this program on a regular basis. But if I come into our bin directory, I can run /Krita, and with any luck, here we have Krita opening up. Awesome. So this right here is a self-compiled version of Krita, which is awesome. So at this point, now that we've got the compile steps down, I could come back out here and go into our source code directory, which was here. I could modify some of this source code. If I wanted to change something about this program, I could change it right here in the source code. And then I could just go back out, clean out my compile folder like I already did a couple times, run the cmake command again, run the make commands again, and build Krita with my own custom modifications to it. And that's the power of open source software. But at this point, we do have Krita installed. We can create a new document here. We can start painting here. And I'm not prepared to do any art here. I'll just do a little simple Nerd on the Street logo. Circle in there, right? Oh, we've got a square tool. How do I change my color? We'll do that up here. Put our square right there, okay. And then we'll just grab some red. We got blue over here. And we got our yellow gold down there. And our green over here. All right, so you can see why I don't use Krita very often, because I am not an artist. But we do have this installed here, and if we go to our help about Krita, you can see that the version is set to 4.3.0 pre-alpha, and it's even got the Git tag that was the current version in Git, the identifier for that specific version that we cloned earlier. So that's awesome, and we have just built Krita. Now, those steps that we just followed are basically what the steps are going to be for most programs, at least most C++ programs, I'll say. The steps that we went through basically were we cloned our source code, we configured our build using cmake. Sometimes, if you're not using cmake, you literally just run a script called configure, but there's usually some configuration that happens. Then you run make to actually build the binary. Then you run install to place those binaries in the necessary locations. Those are the basic steps for any C++ program, which is the vast majority of programs you're going to need to compile on Linux. Obviously, there are other programs out there. Python is not a compiled language usually. I mean, there was some Python code within here, but what we actually had to compile was the C++ part. So that's Krita. We've gotten that out of the way. Now, I hope that's at least a little bit helpful to people who have never compiled before to see the process actually go through from start to finish, see the things that we had to search for, those packages we had to look up and install. Now, I do just want to give you a little bit more of a exposure to this. So like I said, we're going to hop over now from the KDE GitLab instance to the GNOME GitLab instance. Everyone's switching to GitLab these days, and I love it. We are going to compile Nibbles, my favorite worm game for the Linux desktop. I do prefer Nibbles over Ksnake, so take that for what you will. And we are going to do the same instructions here with Nibbles. So we're going to come out here into our Dolphin window. I'm going to finish up closing Krita there. And I'm actually going to move this install directory into Krita/install. All right, and once those binaries are built and installed, I think it should still work even though we just moved. Oh, it actually put an install folder inside of my install folder now, so that's great. But if I come in here into bin, I should still be able to run Krita, right? Nope, it's statically linked the locations of those files. So if you do want to move your self-compiled program after you've compiled it, you will have to recompile after configuring for the correct directory. But we are going to create a new directory here, make dir nibbles, and we will cd into nibbles. And like we did with Krita, we are going to first just scroll through here and look for instructions. All right, so you can see there is a configure file that we'll use. Now GNOME, unlike KDE usually uses cmake in their programs, like I said. GNOME uses Meson, and you can see they just ported to Meson 2 months ago. So I don't see just a how to configure or really, there's not even a README in this project. So I'm just going to Google GNOME Meson compile. I'm going to start page search this. All right, we've got an Arch wiki page down here, which is usually pretty good, but this is for JH build. This is not for Meson. And in fact, this is something in the AUR, not in our official repositories. All right, well, here we go. We've got the Meson website here. They've got a quick start guide for the entire Meson build system. So they've got some commands here for compiling a Meson project. Once again, Meson, just like cmake, will not allow you to build source code inside your source tree. We are going to need to create a separate folder for compiling versus where the source code is stored and then we will end up installing. So let's go ahead and let's just try cloning Nibbles and using this Meson quick start guide. So we're going to come back out to our GitLab instance. Once again, we will take our link here and we will git clone gnome nibbles. All right. So we are going to cd into gnome nibbles. And according to our Meson guide, we should be able to run Meson build dir. So we'll run that. Meson command not found. All right, so let's try sudo pacman-s Meson. And if we're lucky, yes, we just got a package called Meson. So let's try that again now. And could not execute Vala compiler Vala C. So let's try installing Vala C. Not found. So let's go to our archlinux.org website and let's search for Vala C, or we've just got Vala, compiler for the G object type system. All right, so the compiler is called Vala C, but the package is just called Vala. All right, and that's installed some things. So let's try again. Let's remove directory. Actually, here's a good tip for you. If you start messing around in your source code folder that you cloned via Git, I want to remove this build dir directory right now. I could just remove the build directory, but instead of doing that, we can actually reset this directory that we cloned from Git. We can use Git to actually reset it back to the upstream template that we cloned before. And we can do that by running git reset and then git clean-fd. And that will remove anything that you've changed, anything that you've modified. It will reset back to how it was before. And now that we have Vala installed, we can come back to our quick start guide here and let's try running Meson build dir again. Meson build dir. So that's going to create a directory. Looks like we've got another dependency, libgnome game support 1 not found. So once again, in cases like Krita where we've got really good documentation and it lists out the dependencies, we can go and we can install all the dependencies that we need ahead of time. For projects that don't have very good documentation, and I'm not saying that GNOME doesn't have good documentation, but obviously in this case we don't just have a list of dependencies. Sometimes you're going to be installing something from GitHub that one guy made 5 years ago and then he dropped off the face of the planet. And you're not always going to have a list of dependencies. So you just have to try compiling and see what error messages you get. And then you have to search your package manager for packages that might satisfy those dependencies. So let's try libgnome games support. And we've got a package called libgnome games support. So we will sudo pacman-s libgnome games support. All right, and we will git reset and git clean fd, and we will run our Meson command again, and that time it worked. We did not get any error messages. So you gotta go through it one step at a time like that sometimes when you don't have the proper documentation in front of you. And at this point, we can cd into our build directory, and it looks like for Meson we can just run ninja. And it's going to compile. That was very quick. That was a heck of a lot quicker than Krita, and I would hope it would be because Krita is a digital painting suite and this is a snake game. So now we can run ninja test. Ninja test. Let's see what that does. Oh, well, didn't really do much of anything. Okay, looks like there is an install command for Meson as well. So let's try this out. I'm going to make a directory at // install, and we are going to make our destination directory destdir equals home/videos compiling software from source nibbles install. So that's going to be our directory to install to, and let's try just running ninja install. See if that does anything. Subcommand failed. All right. No such file or directory its tool. And the first thing we'll do is pop that into a package manager, and we do have a package called its tool. So we have that installed. So do pacman-s its tool. We do not have it installed. Let's try installing it and running this again. Okay, and it worked that time. So now if we come back out to our nibbles directory and we cd into install, once again we have nothing here. My install directories really aren't working that well in this video. Oh, okay, that's nice. It looks like we have installed to a subdirectory called home videos compiling software from source nibbles install user local. Okay, bin and there's gnome nibbles. So I would like to point out at this point that for my first example, I compiled to a directory that was higher up than I meant to. And for the second example, I compiled to a directory that was lower down in my file system hierarchy than I meant to. However, we have successfully compiled. We can run /gnome nibbles. And all right, looks like we did crash. Settings schema org.gnome.nibbles is not installed. So you know what we do with error messages is we Google them, web search them. Gnome nibbles settings schema is not installed. All right, and on the nibbles homepage, we've actually got a building from source. Now, see, they've got this section of the GNOME documentation that says building from source, but all it's telling you is how to download the code, not actually how to build. So that doesn't help us, GNOME. All right, I think this is another dependency. GNOME settings daemon schemas. Let's copy this and let's paste this into our package manager. Yep, there's a GNOME settings daemon that I probably don't have installed since I'm running KDE. GNOME settings daemon. And so let's install that and let's see if our self-compiled nibbles starts now. It did not. All right, this is starting to get a bit tricky, but let's come back out to our directory here. Let's delete that build. And let's try building this again. Let's start over from scratch now that I've installed another couple of dependencies. So we will git reset, git clean fd, meson build dir, cd build dir, ninja test. Can we just run ninja install, or what will that do? Okay, so see, if I run ninja install, it's trying to run this as root, which I don't want to do because I don't want to actually install it on my system. So we will try installing it to destdir equals actually, let's just say destdir equals install. What does this C flag do that they're recommending that we use? Let's see if we've got a man page for Ninja. We don't have a man page for Ninja. Ninja -- help. All right. Let's try running ninja install. cd install, cd user, cd local, cd bin /gnome nibbles. Nope. All right, well, we do have another package called gsettings desktop schemas. We can try installing this. pacman-s gsettings, that's already installed, all right. All right, so just from Googling around a little bit, I have made a discovery. This is complaining that settings schema org.gnome.nibbles is not installed. We actually do have this installed. If we come back out here and go into our share directory, and we cd into glib 2.0 and schemas, here we have our org.gnome.nibbles gsettings schema. All right, so basically, I know I said I wasn't going to modify my actual system, but I'm going to place a link, a symbolic link, basically a shortcut, from our self-compiled nibbles gschema to right here, and we're going to call it the name of this file, org.gnome.nibbles.gschema.xml, and we need to run that with sudo permissions. Now we are going to run sudo, what was the command? glib compile schemas. Sudo glib compile schemas on the current directory. All right, and now let's try running nibbles again. Hey, it opened up. All right. So I guess even though we were self-compiling nibbles, it was self-compiling it to still read our system's gschema. It did successfully compile this XML here, the XML file for the schema, but then we had to go and actually install it on our system for our self-compiled application to launch. So I would call that GNOME being messy and not self-contained, and I would call that an example of KDE software being better written than GNOME software. The GNOME developers would argue that you should have their software installed on your system all the time and that it's your fault for running into this issue. But at this point, we can play. I want to see how this looks. It crashed, all right. See, it's trying to read all these files from our actual system because we installed it here in our install directory and not our actual system directory. If you wanted to install on your actual system, this is how you'd do it, and then you'd go and copy these files into your actual system folders. I don't know, are these directories hard-coded, or there's gotta be a way to change them on compile time that I just don't know about. Yeah, no, the directory is not hard-coded. So this would just be a matter of figuring out how to compile nibbles while telling it where you want it to actually be. And there's a binary in here. Does this one run? Oh, this one runs fine. Can we start the game in here? No. So yeah, GNOME has their own, they've got GNOME Builder that makes it a little bit easier to do this stuff if you're trying to hack on GNOME apps. Otherwise, it appears that GNOME apps are meant to be installed on your system and not to be played with. This video is already getting quite long, and I want to actually feature our third program here that I had picked out. So we're going to move on at this point to SuperTuxKart. And I am just going to clean up my system here. We are going to sudo remove /org.gnome.nibbles, and we are going to rerun that glib compile schemas command. All right, so I've removed the custom compiled things from my system directory. Okay, and finally, last but not least, let's compile SuperTuxKart. SuperTuxKart actually uses CMake, even though it's not a KDE application. CMake is not a KDE application either. CMake is available for anyone to use, and as you can see, there is a CMake directory here in the SuperTuxKart code. So this is on GitHub, and you see that green clone or download button. We are going to make a directory called SuperTuxKart. I'll just call it STK. We'll cd into STK. And we are going to git clone the SuperTuxKart code. And while that's downloading, let's just scroll through here. Do we have building instructions? Yes, can be found in install.md. Excellent. So in order to build SuperTuxKart from source, you'll need both the code and the assets. So not just the code, which is what we are downloading right now, but we will also need the assets, and they're giving us an svn command to download this. Svn is an alternative source code control and versioning program, an alternative to Git. We can take a look at the SuperTuxKart official website here, and they're telling you that the core code is hosted on GitHub, but the data files, the artwork and whatnot, those are hosted on SourceForge. So we will go ahead and use the command here. We will grab that, and as you can see, I don't have svn installed, so we will sudo pacman install svn. And that should be in our repo there, yep. All right, and now we will try that svn command again. All right, that took a minute to spin up there and didn't give very much output, but now we are downloading all of these assets. So this is really what I'm talking about. Like I said earlier, this is the reason I can't just make a generic video where I show you how to compile everything, because different programs will have different quirks. In this case, they separate out their assets from the code because there's so many assets. SuperTuxKart is an example of a great program that has very well written compiling instructions. They even give us here the list of dependencies that we'll need. So we'll go and make sure that we've got all of these installed before we start. They even give you the specific list of packages to install for Ubuntu, OpenSUSE, Mageia, and Fedora. So if you're trying to install a program, if you're trying to build it from source, and you can't find these instructions, you might want to ask the developer if they have instructions documented anywhere, and if the developer either says they don't have instructions, or if they are not responding, if they're dropped off the face of the earth and you're just dealing with abandoned code. Unfortunately, it is going to take more Googling, like I just had to do with GNOME. You know, there wasn't a Nibbles compiling guide on the Nibbles GitLab page here. I just had to Google around and kind of figure out how to use the build system that they're using. So you'll kind of have to do the same thing if you don't have this kind of documentation for whatever program you're trying to use. We are still downloading assets here, and if I take a look at our network usage, yep, I think we are definitely limited right now by SourceForge's bandwidth, not by my own bandwidth, based on that download speed. You know, we actually can be installing packages while that's downloading here, so we'll go ahead and start doing that. So I'm going to try and split screen us up here. All right, and let's take a look at that list of packages again. So Mesa, I'm fairly certain I have already, yep. OpenAL soft devel, we do not have. So I'm gonna go to archlinux.org just because I prefer searching using a GUI rather than the command line, and we'll search OpenAL. Looks like the package is just called OpenAL. So sudo pacman-s OpenAL. And we will install that. Oh, it was already installed. Okay, well that's fine. libogg dev, libogg dev, libogg. Yep, we've got libogg. Lib vorbis, we've got installed already. Looks like Arch does not append -dev to the end of its package names, which is perfectly fine with me. Lib freetype 6 we do not have. So archlinux.org and lib freetype. We don't have that. If I search lib free, we've got lib freehand and lib freexl. Free type, let's try searching that. Here we go. So free type version 6 is what they want. We've got free type 2 here. Well, let's just try installing free type 2 and we'll see if that gets us through the compilation. Sudo pacman-s free type 2. That's already installed. All right. I think we've already got everything we need installed, honestly. I'm going to keep searching here. pacman-qi lib harfbuzz. Harfbuzz. We've got harfbuzz already. Fribbity we've got installed. Curl I know we have installed. BlueZ we've got installed. Why do we need Bluetooth? Why do we need Bluetooth for a Mario Kart clone? That's interesting. Nettle, spelled it wrong there. We've got that installed. libpng we have installed. zlib I know we have installed, and I'm fairly certain that I have support for JPEG images on my system, yes. So we've got all the dependencies already, which is actually quite remarkable because this is kind of a complex game once again. All right, so to compile SuperTuxKart, they make it super easy for you. Run the following commands in the STK code directory. So let's come here and do that. So we will cd into STK code, and we are going to run makedir cmake build. cd into cmake build. So once again, oops, went in the wrong directory. Once again, we need to create a separate folder for building the code. We are going to run cmake, which will configure on the containing folder. So just like we did with Krita, we could have made this cmake build in another folder next to SDK code instead of making it inside SDK code. That's just a difference in how the projects documented themselves. But cmake, since it's the same tool, it should work either way for either program. All right, and that was pretty quick, and that's done. Now we will make -j8. Once again, you can see this is just an easy way you can say use all of my threads. But once again, I don't want to use all the threads in my processor since I am recording right now. Let's zoom in a little bit more here, by the way, while we're thinking about it. And this is compiling much quicker than Krita. It just goes to show you how complex of a program Krita is, and possibly how well written SuperTuxKart is, although obviously Nibbles compiled quicker than this, being a worm game. All right, and that's finished. And now we should just be able to go into bin, according to the documentation, and run SuperTuxKart. And there it is. And you can hear that music kicking in there. I'm going to turn that a little bit down. And it's asking if we want to connect to a server to download add-ons. Sure. And we can set our local username and everything. No, I don't want to set online accounts up right now. And now we can play single player. Let's pick Conky, since I'm a KDE guy, obviously. We're going to play expert mode here, and we are going to play normal race. Let's just try anything here. All right, and I don't know the controls here, so hopefully I figure those out. Okay, so I do need to hold down the up arrow to go. Good to know. How do I throw things? Space. Okay. And so now we're playing this excellent racing game. All right, and I'm just gonna go into the water here and cool. So I won't make you suffer through an entire game of that there, but props to SuperTuxKart. That is a super easy game to compile. To the commenter who asked about this, I hope this was at least a little bit helpful. That was the general idea for if you're compiling software. If you don't care about trashing your system, right now I don't want to install a custom version of Nibbles onto my system. Once again, I only install package manager managed programs into my system directories. But if you don't care about that, if you're willing to, trash up your system a little bit, have files laying around here and there and maybe reinstall every couple of years to take care of that, then you can absolutely install self-compiled software onto your system in the system directories. Like I said before, since it's just so dependent on the individual application, I cannot just make a one-size-fits-all video explaining how to compile software. And the software, the program that commenter asked about specifically was one that's a little bit more complicated. I wouldn't have been able to really demonstrate it in its full capacity in the same video as I was compiling it. I might make a separate video just about that program sometime, but in terms of compiling, this was how you do it. I do want to say once again, if you have further questions, if there is a specific program that you are trying to compile and it's not working, as long as it's not a GNOME app, I would love for you to head over to the Nerd on the Street forums at nerdonthestreet.com, head into this Tech Talk section and start a thread about whatever program you're trying to install, whatever program you're trying to compile, and I'd be happy to help out in any way I can. And also, if this video was helpful to you, you can go to nerdclub.knots.co and consider becoming a Nerd on the Street Nerd Club member. It's just $3 a month, and you can help me make more videos about free and open source software. I've been making these videos for 7 years now, and any support would be greatly appreciated. But with that, that's everything I had to talk about in this video. So I'm Jacob Kaufman, I'm the Nerd on the Street, and I'll see you guys in the next one. Bye.